All right. Unit 5, Lesson 1, Investigation, where we're going to be talking about functions, okay? Now, we have been talking about functions all along, or so far. We've been looking at tables that have an x column and a y column that make a function, right? Now, a lot of the function stuff we've been looking at have been doing with graphs. We won't always use x and y for our variables, though. So whenever we have an ordered pair and we're talking about functions, the inputs, which we're used to being the x's, always goes first in the ordered pair, and the output will always go second. Okay, that's something that's kind of often overlooked. So maybe on your notes, write by name. Maybe you want to write input, comma, output, just so you have it there. All right, so that's something we should at least talk about. All right. So they won't always be x and y, but today we're going to start with inputs and outputs being x and y. All right. So write this at the top, kind of write by the name. Be a good thing to write down. Now, so far when we've been looking at functions, we've been looking at graphs and parabolas and squiggly lines and different things. So first off, is this a function? Yeah. Will every input have only one output? Yeah. Have you tried every input there, Jessica? You plug every number in for this? No, but you're shaking your head. You're pretty satisfied this is a function, right? Yeah. How do you know? How do you know it's a function? This is a number. How do you know? Just, okay. Whitney, how do you know?
Because they're psychic.
Yo, Whitney, how do you know?
I'm psychic.
No, you're not.
Why are you
Sorry. So, what is it?
Linear.
Good, Whitney. This makes a linear. Makes a line, right? It's a linear equation. When I graph this, it'll be a line, won't it? It will look like this, where it crosses at 5 and has a slope 3 over 1. Raises 3 right, or raises 3 for every one to the right. Right? Does that make sense? Does that pass the vertical line test? Yeah, so it's a function. Right? So this is a function. We know that because it makes a line. Okay. Now you guys are comfortable using equations like that, right? Right? Now, today we're learning about something called function notation and domain and range. So that right there is an equation, and I'm going to show you how that can be rewritten in function notation. Okay? So, function notation uses these squiggly lines like we have, or squiggly f's like we have right there. It's a script f. All functions are usually written with a script letter. So the way we would write this in function notation, we would write f of x, which means a function of x, good, equals 3x plus 5. And that is function notation. So what Yovik is saying is all we're doing is we're switching this for that. So basically we're saying f of x equals what? Y. Right, does that make sense? No. Okay. F of x, this stands for my outputs. Okay? What up here stands for my outputs? Y. So all I'm doing is I'm substituting in f of x for y. Okay? We'll get more comfortable as we go. Bruno, can you shut it off, please? Thank you. So, f of x equals y. I substitute the equation in for y, and we get f of x equals 3x plus 5. So, basically, this is our equation for y. And we're substituting this in for y. Sorry, we're substituting this in for y to get that. Does that make sense? Okay. And this right here, this is called function notation. Now this function notation has a lot of meanings to it. Right? First off, where do I find my input in here? What is my input in function notation? The x. Good. This x right here, this is our input. So whatever number we're inputting, it comes from that, or goes in for that x. So if my input is 1, I plug in 1 in for x here and here. And we get a number. How many numbers do I get?
1.
Just 1, right, Alyssa? Right, Serena? No teaching on the floor. That's all up here. Okay. All right. Any questions? Any questions about how that's my input? Now, what represents my output? Y is my output, right? What's in the same spot as Y? No. Nope.
The number. Slope. The equation.
The equation. The equation is my output when we plug in a given x, right? So this will give us our output. And that's why every ordered pair is input comma output. Because if I plug in x, I plug in 1, right? 3 times 1 is 3. 3 plus 5 is what, Jamira?
3 plus 5, 5, 6, 7.
8. Okay. So the ordered pair would be 1 comma 8, right? Maybe you should pay attention up here. Luis, put it away unless somebody have it. Okay, in your pockets. Okay. Well, throw it away then. No, go throw it away. It's trash. Go throw it away. Yeah. So, any questions about how I wrote this?
Do we have to write it like that?
Okay. I exaggerate my script F because I have kind of sloppy handwriting. But you know, like italics and regular writing. Okay. Think about this F as it's in italics. Okay. That's how I get that. All right, it's in italics. Just function notation and put it right here. Okay. Just go across that whole top rectangle. And if you need more room, because I know some of you guys are big writers, if you write down this margin right here, about put as far over as that sentence below, then you should have enough room for the rest of it too. Okay. Either you guys write big or I try to put too much in small spaces. Either one.
You try to write too much.
Okay. I'm sorry. I like to talk. You know this. All right. Any questions about how we got inputs and outputs right there?
Are you recording?
Yes.
Hello.
So this right here, guys, this is function notation. Okay? So what does this f of x equals y mean? What does this mean? Well, there's a couple ways we can pronounce this. Okay, so in quotations, this is how I pronounce it. This is saying f of x equals y. That's one way to say it. F of x equals y. Another way to say it is, y is a function of x. So that's another way we can say it. So f of x equals y, or y is a function of x. Now, David, you're probably wondering if all we use is f's, aren't you? Yeah, you can use any letter there, as long as it's written kind of script-like or italic-like to denote it's not a variable. All right. So if you saw this in written text, and I don't think I forgot to do this in your notes, maybe I didn't, but the functions are usually in italics. So it could be f, it could be g, it could be h, it could be c, it could be b, right? It could be any letter in the alphabet, but you'll know it's the function because it'll be written in italics. Okay. Or I'll tell you too because I forgot to switch it, like on your exam. All right. But it will usually be written in italics. Or if you see something like this, f of x equals this, it's not saying f times x. It's saying the function of x equals that. So to find my outputs, we use that equation. Okay. Does that make sense, guys? So what does this mean for us to do? What if I want to find this? F of 5. We plug in 5 for x, perfect. If they give us something and say, find f of 5, that's how I say this, f of 5. Okay? Find f of 5. That means 5 is my x, 5 is my input. So that means we do 3 times 5 plus 5. Okay? The 5 in the parentheses came because it was my input. The 5 by the plus sign was just part of the equation. Does that make sense? Okay. What's 3 times 5? 15. What's 15 plus 5? 20. So what this means is that when 5 is my input, what's my output? 20. Okay? What that means is this line over here that we graphed, just kind of a quick graph, this means that the point 5, 20 is on that line. Okay? Input, comma, output, right? So you want to write that little note to yourself. 5, comma, 20 is on the line. You're probably saying, what line? Well, 3x plus 5 is a line. Right? 520 is on that line. Does that make sense? Now, if I plug in 5 again, will I get 20 again? Or will I get something different? We'll get 20. Every time we'll get 20 because this is a linear, which makes it a function. Good. One input has only one output. Does that make sense? Sure. Now, sometimes they get kind of tricky on us. And they write something like this. F of x equals -10. I know. Trying to confuse you. Okay. Oh, I didn't use -10 last time. Let me fix it. Sorry. F of x equals 10. Okay. They're trying to trick you. What are they giving you here? The outputs. Right? They've given us the outputs. So then, Alyssa, what do we have to find? If we know the output, what do we have to find? Okay, keep your head up, that'll help. Okay, Serena, same thing. If you're going to sleep or do that again, you're both going to stand. Okay? Now, sleeping time. Pay attention. Okay? If they've given us the output, what do we need? The input. We need to find the input. Input, output go together, right? So here we have the output. Let's find the input. Right? So that means this is my x or y value. Y. So in this equation, the 10 is like my y, right? So we get something that looks like this. 10 equals 3x plus 5, because that's the equation they gave me back here. All right? So can we figure out what x equals? Yes. Yeah, what do we got to do? We got to use algebra. So subtract 5 from both subtract 5 from both sides. 10 minus 5 is? 5. Good.
I like algebra.
You too. It's kind of fun. Always has a definite answer, though, right? It's not like,
Maybe this.
yeah. Why did World War II start? You know, it has like 7 different answers. This has 1. That's why I like it. Yeah. But this doesn't make a good movie, though, does it?
No.
No. All right. So now what do I do? 5 equals 3x. What do I do now? Divide by 3. Good. Serena, pay attention up here. Stop talking to Alyssa. 5 divided 3. You guys all have calculators. You can figure this out. 1.6 repeating. Okay. Yes, we can get decimals. That's okay. Okay. So that means if I were to take 1.6 repeating and put it in here for x, what would I get out?
10.
We would get 10. Yep. If you want to be exact, put in 5 divided 3. Do 3 times parentheses 5 divided 3, close parentheses plus 5. Okay? And then you'll for sure get 10. And what that shows me is that this input has one output. And it is 10. Does that make sense? So where would I find 1.6 comma 10? On the line. Right? Means 1.6 comma 10 is somewhere in here on the line. Right? Because it's a function. Okay. Any questions about that? Are there any questions? No? Okay. On to the next thing. Domain and range. Some of you may know about domain and range.
Selfie time.
Some of you may not. Nope, no selfies.
You're taking a selfie of yourself.
Oh, I took a selfie of the buttons on my shirt. Nice. Before practice. All right. What was your guys' favorite toy when you were in elementary school? What did you have? Toy car? Well, that's not fun to use. What'd you say, Whitney?
Tamagotchi.
I can't pronounce that, so. Brats? Okay, I think someone said that earlier, too. Those ones are pretty popular for girls' grades. Serena, what were you going to say? What? Nothing? Okay.
Tamagotchi.
Oh my goodness, I don't know what that is.
Oh.
Alright, well my favorite was Ninja Turtles. Okay? Not the new Ninja Turtles, the old school Ninja Turtles. They're a lot cooler. If you don't believe me,
Power Rangers.
if you don't believe me, eBay it. Power Rangers was just a knockoff of Ninja Turtles.
Beanie
It was for people who didn't always want to be a hero. See, Power Rangers, they could take their hero off. Ninja Turtles, they never could. They're always a hero. Alright, let's talk about brats though. So Andrea, you're going to be my aficionado on brats. Okay? How many do you think you had? Just take a guess. 30. Okay. Just dolls or the action figures? Dolls or action figures? Dolls. Okay, mine were action figures. Very similar, except mine don't have hair. They were just plastic. Hers had hair, right? Doll action figures. Difference. Guys, if your action figure had movable hair, it's a doll. Alright, so Andrea, you had about 30 of the dolls, right? Okay, did you have like anything else or just the dolls?
Gotta have the shoes.
Clothes and shoes. Okay. Besides the accessories for the doll, did you have? Was there like a car that had a jacuzzi in it?
My car had a radio in it.
You had the limo. Okay. Did you have a house too?
Yeah.
Yeah. Okay. So now let's say you're at your house. You have your $30. You have your house in your car, or your limo in your car. No, your limo in your house, right? How extravagant. All right. We'll just cut it off at there. $30, one limo, one house. Okay. Now let's say you're going to your grandma's house for the week. Okay, or your aunt, uncle, whoever. You're going to someone's house for the week, and you want to take your toys with you. What ones are you going to take? You're going to take all 30 with you?
Yeah.
You're not going to take any clothes?
You gotta have a little carrying case. I used to have a little carrying case.
Okay, so how many can you carry in the suitcase?
All of it?
All of it? My goodness.
Well, you would have to.
I would shove
Okay.
them all in the house. Yeah, you can just carry the limo in the house and then put all the brats and clothes in a little carrying box.
Okay, you guys are killing my idea. All right, now when I was your age, or not your age now, but your age then, all right, if I was going to someone's house, I wouldn't take all my Ninja Turtles with me. I'd be carrying a big Tupperware container. It was heavy. It couldn't fit on my bike. All right, so I would take like 5 or 6, my 5 or 6 favorite. Make sure I had at least one vehicle they all could ride in. All right, maybe have some of their weapons with them. But I wouldn't take the whole box because that's all my toys, right? And what if I left them there? Would I want to leave all my toys there on accident?
Yes. I would do it.
Well, sometimes you forget. You spend the night, wake up in the morning, you just forget.
No,
Right?
never forget your toys.
Sometimes you do. All right. Sometimes you forget your phone. That's more important than your brat styles, isn't it? Now it is? Okay. But, so I would take, let's say I had 20 Ninja Turtles. I would take 5 of them with me to my friend's house. Right? Am I taking my whole set of Ninja Turtles or just a portion of it? Just a portion of it. I'm taking what's called a subset. Okay, a little bit of my Ninja Turtles. Okay? So, hopefully, what I was trying to get Andrea to say was that if she's going to her grandma's house, she'd take like 2 or 3 brat styles with her, and maybe the limo. Okay, 5 and maybe the limo with her, because she don't want to leave it all there, right? Right? What if her grandma has a dog and eats them, right? You don't want to lose them all. Okay? So, you take a subset with you. You take a smaller portion of the greater picture. Right? Now, the domain is the same thing. Because if I ask you to think about all the numbers, you can give me any number that goes from negative infinity to positive infinity, right? Right? The domain is not all those numbers for every function. Okay? It can be. That's called the real numbers. It can be. But it's not always. Right? The domain, guys, is the set of values that could be an input. Okay? So a domain is the subset. So that means not the whole thing, the smaller portion, right? It could be the whole thing, though. The subset of numbers that could be an input. The subset of numbers that could be an input. That is the domain. The subset of numbers that could be an input. And subset, guys, is just a word that means not the whole thing, it's just a smaller portion. All right? So the $5 that Andrea took with her is a subset of her 30. Does that make sense? The 3 Ninja Turtles that I could ride my bike with were a subset of my whole big plastic container of Ninja Turtles.
You put it in your basket.
I didn't have a basket. I had my paper out bag. Yes. Because there was Raphael was my favorite. There was Raphael, traditional Raphael. There was astronaut Raphael. There was Green Beret Raphael, he was like part of the army. There was football playing Raphael. There was Back in Time Raphael. There was movie Raphael. They had 3 movies come out, so they made one for each movie that looked like the guy exactly like in the movie. There's Samurai Raphael, so like a samurai head on it, right? And then there were all the bad guys. There was Shredder, Super Shredder, Rajar, Toka, Bebop, Rocksteady, all these things. How do you guys not know these?
How do you know this?
Because my things get stuck in my brain and they just stay there. I bet all Drake could name all 30 of our brat styles right now.
No, I
You
couldn't
couldn't?
do it.
I know
I guess it is
that's
true. Okay.
Yeah, that's Sasha.
Chloe.
Chloe.
Jasmine.
See, now I don't feel so bad.
That's it.
And they had prom, Chloe, probably, right?
Oh, then there was a boy, Cameron.
Oh, yeah. Skip her off.
And before we get too far off topic, the domain then, guys, you can just think of it this way as all the inputs. You want to think of it as like a short version, all the inputs, or all the possible inputs. Either way works. I still have my Ninja Turtles, by the way.
You have them.
Are you serious right
They're
now?
at my parents' house, though.
Do not tell
Your
anybody.
parents are gonna
else,
throw
okay?
it out.
Okay, I think everybody knows now because I'm recording it.
Nobody watched
Is
it.
your wife now?
Hey, I have 8,497 views I looked this morning.
Oh wow.
Total.
Video?
Not a big
One
deal.
video.
Thank you. Not 1 million, though. Yes, my wife knows because when we go to my parents' house, my daughters play with them. I just heard out all the
You let
Don't
your
you
daughter
have a
play
son?
with those things?
I do not. I have a dog. He's a boy. Yeah, why wouldn't I? Alright, range. They're still cool. Not like the new Ninja Turtles.
Wait, what if she breaks
Alright,
it? Then what?
that's fine.
That's fine.
Some of the arms are missing already anyway. It's kind of rough when you're playing with Ninja Turtles. Alright, range. So if the domain is the subset of all the possible inputs, what's the range? The outputs.
Those
Okay?
six, seven,
The range is the subset of all numbers, or the subset of numbers that are outputs. Right? That's the range. Now there really is a lot of outputs for Brat Styles and Ninja Turtles, besides just pure unadulterated fun. Right? But that's about it. Alright. You can think of it this way too as all the outputs. Any questions about that? Can you go to sleep? I'm sure you can, but I'll make you stand up.
But if does
You can sleep
anything
staying out. I don't want you to do it. All right. Domain and range. There are 2 other things we can talk about, and then we'll be done. Then we can do some practice. Practical versus theoretical. What is the difference? One is practical, one's theory. Theoretical makes you think theory, right? Which one is real?
Theory.
Practical is real. Which one's theoretical? Or which one's not real?
Theory.
Theoretical isn't real, right? Now, when we're talking about practical and theoretical, practical versus theoretical, this applies to domain and range. Okay? And we'll use D and R for short for domain and range. Okay? Okay. So, not Department of Natural Resources, this is D and R, not D and R. All right. I actually Googled it. Whenever I get posed with a word that I don't really know the definition, so I like to Google it. So, theoretical. Excuse me. Theoretical is an adjective. It means concerned with or involving the theory of a subject or an area of study rather than the practical application. Hey, it says practical right in there. It's kind of interesting. Then practical is also an adjective. It says this. Of or concerned with the actual doing or using of something rather than with the theory and ideas. So they both reference each other, right? So they seem like they are what? Opposites. Right? They are kind of opposites of each other. Not opposites like that now. Not opposite like positive and negative, but just opposite in terms of what they apply to. All right? If we're talking about a practical domain or range, I guess I should give you a little context. Does math always just deal with equations? Or does it sometimes have a context to it? Okay, for example, we just had that Valentine's dance, sweetheart dance, whatever we called it, right?
Waxing.
It costs money. Snow coming. Thank you. It costs money to have a DJ, right?
Yeah.
It costs money to have snacks.
That's
We
what
didn't have
You have snacks?
Yeah. Kisses.
Kisses, good. Hershey Kisses cost money. It costs money to have punch. It costs money to have a photographer, right? All that costs money. No one was a photographer?
No, we took pictures ourselves.
Nice job.
They put a little thing on the wall and said take a picture.
Oh. Well, probably because last time the photographer didn't get much use because you guys probably use your cell phones for it. Then right to Facebook with it, right? All right. So, but all that stuff costs money, right? Right? Cleaning the building costs money. Okay. Now, how do you know how much to charge for tickets if all this stuff costs money?
You gotta do the
Yes,
theoretic.
there you go.
Okay. So we just said in general it costs $1,000 to have all those things, right? Just in general. How could I figure out how much to charge for tickets if I knew 500 people were coming? Divide what? Okay, we took 1,000 divided by 500. That's how much I would charge so that we break even, right? Okay, now that is math with a context. Okay, it had a story problem along with it. If I said, what's 1,000 divided by 500?
2.
Same answer, 2, right? That's math without a context. Okay, theoretical domain, or domain and range, applies to the domain and range that work in terms of mathematics. Okay? So theoretical is the domain and range that work with respect to math. I'm just going to put math. I'm actually going to put a period behind it. Not to have my sentence, but to say mathematics in general, like the whole math as a whole. So domain and range, theoretical is the domain and range that work with math, just in terms of the mathematics of the problem. So, to give you a good example of this, a wonderful example. If I have this equation, y equals the square root of x, Jamira. If I have an equation, y equals the square root of x, that equation has certain numbers that I can plug into it, doesn't it?
Yeah.
Okay. What's a number I can plug into this?
Can?
Yeah. Nope. What's the number I can plug in for x? That's fine, Bruno.
1.
1. I can plug 1 in, right? Will I get an answer? Yeah. Can I plug 2 in? Yeah. Can I plug 3 in? Okay. Can I plug 1.5 in? Yes. Can I plug in 3 halves?
Yes.
Can I plug in 0?
No.
Try it if you don't believe me. You could square root of 0. What do you get?
0.
0. What number can I not plug in? A negative. So mathematically, I can plug anything in here that's not
-0.
negative. So my domain will be all non-negative numbers. Notice I didn't say all positive because I wanted to include which number?
0.
0. Good. So all non-negative numbers. Now what will my range? What will I get out? If I plug in a non-negative number into this, what will I get? I get a positive number, right? And 0. Because I plug in 0, I get 0. So then our range is actually the same as our domain. All non-negative numbers. Now, it's not always the case that your range and domain are the same, but in this case it is. So that's how we have theoretical in terms of the math. Right? Does that make sense? It works in terms of the math. Right? Now, a practical domain and range are the domain and range that work in the context of the problem. Ladies. How the time you go and eat?
That was my calculation.
You might. Yes, you will. Okay. So practical is the domain and range that work in the context of the problem. Right. So let's talk about that homecoming homecoming example. Snow coming. So
Everybody's just
cost
talking today.
equals 1,000 divided by n. C stands for cost, right? N stands for what?
Number of students.
Number of students, perfect. 1,000 was the total of everything, total money we had to put up to have snow coming, right?
Yes.
The cost isn't the cost of the event, but the cost of the snow coming tickets, perfect. Okay. Here we have a situation that has a context. Mathematically, can I plug in a decimal for n?
Yes.
Yeah, can I plug in a positive number for n?
Yes.
Can I plug in a negative number for n?
No.
No, mathematically speaking.
Yes.
Will this work if I plug in a negative number? Yeah, so theoretically, its domain is both positive and negative. Can I plug in 0? We cannot divide by 0, can we? So theoretically, this domain is all positive and all negative numbers, right? Or all numbers except 0. But practically, in terms of the context of the problem, can I have a partial person?
No.
No. Can I have a negative person? I'm talking about number-wise, not emotionally.
No.
Can I have a negative person?
No.
No. We can't have negative people, can we? Okay.
Yeah.
It's a lot easier to be positive anyway. Alright? Except for they give me empty counts, right? Alright. So, in terms of the context, our domain is only positive, not just positive numbers, but they have to be whole numbers. 1, 2, 3, 4, 5, 6, and so on. They can't be decimals. So domain here, which is practical, is going to be positive whole numbers. And notice I'm not putting 0 because we cannot divide by 0 here. Right? This means somebody is going to go to the dance. Okay? If only one person goes, it's going to be expensive.
That would be really sad.
Them by themselves with the DJ and the food. Or the kisses and the punch. Okay. Now, what would the range be? Positive whole numbers? I bet it's not. What's 1,000 divided by 3? Positive, not a whole number.
Yes.
Okay. So the range can be any number?
Positive number.
Oh, any positive number. Yet there's no way I can divide that by a number and get 0. I can get something that's really close to 0. If I divide that by a billion, it'll be close to 0, but it won't be 0. Right? Does that make sense? Does that make sense, guys? Any questions? Any questions?
Yeah.